Welcome back to another session on our packet tracer activities. Today we are going to configure the alt standby redundancy protocol on our devices. So let's look at the objective. So we have the addressing table and all the necessary information we need to use over here. So let's go through the objective of this particular packet tracer activities. So in this packet tracer activity, you will learn how to configure the alt standby router redundant router protocol to provide redundant default gateway device to host on local area network. After configuring the alt standby redundancy protocol, you will test the configuration to verify that the hosts are able to use the redundant default gateway if the router gateway device becomes unavailable. So the objective is to configure the alt standby redundancy protocol active router and also configure the alt standby redundancy protocol standby router and then verify the HRSP operation. So based on our discussion when we are explaining the alt standby redundancy protocol, you know, it is a more like a protocol that enable us to have more like a backup router. Maybe if you are connected to your internet service provider or you want to have 2 or more internet service provider, so you can configure 2 routers to be connecting to 2 different internet service provider, and one will be active and the other one will be a standby. So in case if the other internet service provider is down, the other router can take up and then there will be a continuation in your service and there will not be any downtime. So let's go through the scenario and observe what we are trying to achieve. So spanning tree protocol provide a loop-free redundancy between switches within a local area network. However, it does not provide redundancy default gateway for end user devices within network if a network router fails. So first up, redundancy protocol HSRP provide redundant default gateway for end devices with no additional end device configuration necessary. So by using the first up redundancy protocol, 2 or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. So in this packet tracer activity, you will configure a Cisco alt standby router protocol, HSRP, which is a what? First up redundancy protocol. You will configure the HSRP on a router 1 and router 3, which serve as a default gateway for the host on local area 1 and local area network 2. So when you configure the HRSP, you will create a virtual gateway that uses the same default gateway IP addresses for hosts in both LAN. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. Because of the hosts on the LANs are configured with the IP address on the virtual gateway as the default gateway, the host regain connectivity to remote network after the HRSP activate the remaining router. Basically, that is what we are trying to achieve. So in case you have 2 local area network connecting to the same devices, to 2 different routers, router 3 and router 1. So when we configure this router 2 and router 1 as an HRSP, they are going to share the same virtual IP address, and it is that virtual IP address that we are going to assign to our devices so that they will not even notice when one of the router is down or one of the router is up. So the first one is to first verify connectivity, trace the path to the web server from PCA. Go to PCA and open a command prompt, then trace the path from PCA to the web server by executing the trace-sat 209165200256. So that is a method of confirming which router is your device using. So from PCA, we have to go to the command prompt and type the what? Trace-sat, then 209.165.200.226, right? So with this now, we have to observe how the device move the message from one point to the other. So you can see initially it goes from what? 192.168.1.1, which is the default gateway, right? And then from there, it moved to the what? The 10.1.1.2. And finally, it moved to the 10.100.100.2. And lastly, it is able to reach the server. So if you go to our table and let's see how it moves. So from the table, it first moved from the 192.168.1.1. So which one is that? 192.168.1.1. So which is the G01 interface on R1. So that is how it moves because it is directly connected to the R1. And then from there, it moved to the 10.1.1.2. So the 10.1.1.2 is a router on R2. So the message moved from router 1 down to what? R2. And then it moved to 10.10.100.2. So the 10.10.100.2 is what? The internet, right? Which is what? This particular interface. And then finally, it is able to reach the server. So it moved from router 1 to router 3. From router 3, then it moved directly to the internet. And from the internet, it moved to the server. So the message moved from PC1, go to router 1, from router 1 to router 3. And from router 3, it moved directly to the internet, right? And then it's able to reach the server. So that's basically how it moves currently. So which device are on the path from PC8 to the web server? So we are able to see that router 1 is on the path, router 3 is on the path, and then router 2 is on the path, then finally to the what? To the web server. So now trace the path on the what? PCB also. So let's trace the path on PCB by clicking on the command. So this is how you can know which path does your message follow before it reaches its final destination, 209.165.200.226. And then if you observe also, it also moved from what? First, it go through the .1.3. So the .1.3 is which one? Over here, .1.3. 198.1.3, that is router 3. It moved directly to the router 3. And from the router 3, it moved directly to the .1.12. So .1.12 is router 2. So it moved directly to the router 2. And from the router 2, it moved directly to the what? The .100.100.2, which is what? The internet. And from the internet, it moved directly to the what? To the web server. So that is the path they are following currently. So for PCB, it moved directly from router 3 to router 2, from router 2 to the internet, while from PC1, it moved from router 1 to router 3, from router 3 to router 2, and then from router 2 directly to the what? To the web server. All right, so that is the path they follow to reach their final destination currently. So now observe the network behavior when R3 becomes unavailable. So now select the delete tools from the packet tracer tools bar and delete the link between R3 and S3. So now if you do that, the link between R3 and S3. So if you delete this particular link and then select back, so open the command from PCB, execute the trace start with the web server. So now we have to go back to the PCB, execute the same command, and now you notice that it will not be able to reach the server. So that means currently now there is no any redundant link that can enable PCB to reach the server when the link where it is initially connected to has been what? Disconnected. So you can see request timeout because it is not able to reach any particular link. So compare the current output with the output of the command from the step 2. What are the results? So you can definitely see that the result is timeout and it is not able to reach. So click the connection link in the lower left corner of the PT, locate the copper straight through and reconnect back. So now we are to connect back the link after this one must have finished. So definitely it's not going to reach. So let's just stop it. And then we can reconnect back our link by using the copper straight through. So just connect from this. Connect is locked by auto. Let me see. Connect from this to this particular port. All right. So it's going to deactivate that. So G02 on R3 and G01 on this switch, right? So after the link light on the connection are both green, test the connectivity by pinging the web server again, and it should be successful. So we know that it should definitely be successful. We try it back now. Once it is turned back to what? To green. So let's wait for it to turn back to green, or we can use the simulation tools. But simulation is not allowed. So we'll just wait for it. And when we press it, it's going to reconnect back if it is able to connect. So, okay, it is showing green already, and it should be able to make its connection successfully now. So you can see we are able to successfully connect it, unlike when we disconnect it. So now the first thing we have to do is to configure the HRSP active and standby router. Configure HRSP on R1. So interface G01 on R1, we have to configure it as this what? Using the standby version 2. And we are going to give it the standby 1 IP address to be what? 192.168.1.254. Right? So we go to R1, press enter, enable, then config T. Then we enter the interface G0/1. Then we are to use the standby standby version 2. We have version 1 and version 2, so we are trying to make sure that we are using version 2. Then standby 1, standby 1. Then IP is going to be 192.168.1.254. All right. Then we are to configure the priority. Standby 1, priority 150. Then standby 1 preempts. So we are going to explain, we have already explained all these things in our previous class. So I believe you should understand what we are trying to achieve. And then with that, we have configured R1 as our what? The active router. So we are to configure R2 as the what? The standby router. So by doing this, we only repeat step 1B and 1C without doing step D and E. So what we have done so far is that first, we specify the HRSP protocol version. We have specified the version of the HRSP. We also use the interface G02 as what the the active router interface. And then we configure the IP address of the virtual IP default gateway. So by using this particular command, standby 1, IP 192.168.1.254. So this particular IP address is now the virtual IP address of our default gateway. So the address must be configured on any host that require the service of the default gateway. It replaces the physical IP interface address of the router that has been previously configured on the host. So multiple instances of HRSP can be configured on a router. You must specify the HRSP group number to identify the virtual interface between the router in a what HRSP group. This number must be consistent between the router and the group. The group number for this configuration is 1. So that 1 is serving as a group number. Then designate the active router for the HRSP group. It is the router that will be used as a default device unless its face or the path to it becomes inactive or unusable. Specify the priority of the router interface. The default value is 100, as we have discussed in our previous class. So a higher value will determine which router is the active router. If the priority of the router in the HRSP group are the same thing, then the router with the highest configure IP address will become the active router. So in just in case, if you forget to configure this particular value, the router with the highest IP address is going to serve as the active router. And then you have to use the preempt. So if it is desirable that the active router resume role when it becomes available, configure it to preempt service of the standby router. The active router will take over the gateway role when it becomes active again. So we have previously explained this during our module on the HRSP explanation. So we have explained that whenever you use the preempt, if one of the, assuming now as we are configuring the router 1 as the active router, so if router 1 go off or it is unable to deliver the service and router 3 take over, so whenever router 1 comes on again and is back on, you should be able to take over all the active signal that is sent through it instead of going through the R3. So that is basically the use of the preempt as we have explained during our class presentation. So now we are to configure the router 3 as the standby router. So we are going to do the same thing. Enter the enable privilege mode, config T, global configuration mode, and then we are to use only the step B and the 1C. So we use the interface that is connected to it. So which interface is it? So we have the interface G0/0, which is the interface that has been assigned with the interface that has been assigned to the switch 3, right? So let's confirm that just to be sure. So configure the R3 interface that is connected to the LAN 2. So definitely we are going to use this particular interface, which is the G0/0 on the R3. So interface G0/0, and then we are going to configure the standby version. So standby version 2. And then from there, we'll put the IP address standby 1 IP 192.168.254.1.254, right? So with this now, we have configured the virtual IP address for this also. I forgot to put the no shutdown, even though it is activated already. So no shutdown, and then we can exit that. So with this now, we can verify our HRSP configuration. So what are we missing already? So let's see. Interface G01, preempt, priority, non standby preempt. Configure the ethernet that's connected to the LAN. Repeat only step 1, B, and 6. Verify this, and then what is it missing? So nothing is missing, but it seems our completion rate is still less. So let's see what is missing. The default gateway for PCB is wrong. And then the default gateway for S1 and S2. So we need to change that. So now, after we must have changed the virtual IP address, we need to change the default gateway on the devices also. So from this now, we change it from .1.1 to 254. And then the other side too will do the same thing. Then also on the switches, we have to configure the default gateway. So enable config T, then IP default gateway will be 192.168.1.254. And then exit. So we do the same thing on the other switch. So 192.168. Okay, sorry. Enable config T, then IP default gateway 192.168.1.254. And then we are done with this particular activity. So basically what we have done is that we have configured an HRSP whereby we make router 1 as the active router and router 3 as the standby router. So whenever router 1 is not active, the device is going to find another route to pass through its message. So let's try to simulate that and see what we have done so far. So from PC1 now, I'll go back to the command prompt and then press on the trace start. So now if I press on the trace start, observe what is going to happen now. So you can see it moved from the 192.168.1.1, and then we'll have the 10.2.2, and then this 100, and we are able to see, let's try it again. So the same thing is able to pass message. And now when we disconnect router 1, so let's disconnect it and see what is going to happen. And then we are trying to send a message now through our PC1. So let's try it again. And then let's observe what is going to happen. So you cannot see, instead of it to fail, it now goes through the what? The 1.3. That means it is now passing the message through the router 3. So that is how it will be able to still be able to reach the server without any problem. So you can see it is successfully able to reach the server. So now let's reconnect back our link and see what is going to happen. So from router 1 back to the Giga Ethernet 2, and then once it has successfully connect back, we are going to try to ping it again. So this time now, it is still following 3 because it has not completed the connection. So once the connection is complete, we'll try it again. So let's wait a minute. Okay. The simulation is not allowed if not. Okay, so now it is back. So we can now press Ctrl C, and then it should be able to allow us to connect back through the first router. So basically that is how all standby redundancy protocol work. If router 1 is not active, then it will go through the router 3, or if router 3 is not active, it will go through router 1. So let's simulate that too. If we disconnect router 3 now, and then we ping from PC2. So if we ping from PC2, PCB, Then we'll try to reach the default gateway, and we should observe that it's going through the router 1. So remember, on our setup, we put the virtual interface on and not the respective interface. So if you click over here, you can see that we are using the virtual IP address interface as the default gateway and not the individual interface. So that's how it is able to achieve this particular continuation of connection, irrespective of whether one of the router is down or not. So that is the end of this particular lab. So thank you very much until we meet in the next Packet Tracer activity lab again.